I'm Perry Goldstein with Air Hydropower, and today for our hydraulic tip of the day I'm going to show you how to properly set up a pressure compensated piston pump with a relief valve. And the reason we have the relief valve is because the compensated piston pump is fairly slow to respond to differences in flow command. It'll take a piston pump about 100 milliseconds to come off stroke, and if a cylinder hits the end of stroke or a valve shifts, that can happen in 15 or 20 milliseconds, we get a very large pressure spike. So to prevent that, we'll put a fast relief valve in our circuit with a piston pump. But it's very important that we keep the relief valve set, the crack pressure set, about 200 psi above the pump D-stroke pressure, or the relief valve will remain open all the time and will generate a lot of heat in the system. So I've got a variable displacement piston pump here. I've got my spike control relief here. We've got a clamp-on ammeter on the motor. We're going to turn, we already have the compensator and the relief turned all the way down. We're going to start the pump. We're going to bring the relief valve up. We're going to turn the relief valve basically up all the way, so we know it's not going to open. We're going to bring the pump pressure up to 200 psi higher than where we want it to actually operate. And our motor amp should stay relatively low because the pump's de-stroked and we're not doing any work. I'm going to start to back the relief valve out. When we see the amp load of the motor increase by 2 or 3/10 of an amp, we know the pump's starting to come on stroke a little bit. The relief valve is just starting to crack. At that point, we're going to back the pressure here down from, we're going to set the pump at 800, so we're going to bring it up to 1,000. We're going to back the pressure down until we get a little bit of difference on our amp meter. We'll lower the pump to 800. The pump should get very quiet. The D-stroke amps will come back down to about 18 or 20 amps on this 20 horse motor. And we should hear no flow in this tube, and we should have no heat generation in this block if it's set correctly. So we'll go ahead and start the motor. We've already checked rotation. We've also made sure that our case, always be sure that you fill your pump case before you start any kind of a piston pump. So we start, and we have basically no pressure. The relief valve is turned all the way down, so the pump is on stroke. And we have very little back pressure for the relief. I'm going to start to turn this up, and you'll hear it, the pump D-stroke get very quiet, and I'll put several turns. This relief valve is a 2,000 psi range, so it'll go higher than we're going to set it. And now we're at about 300 psi, and I'm going to bring this pump up to about 1,000. Remember, we're going to set it for 800, but I want to get the relief set. Our amp draw, about 18 amps right now. So here our pump compensator set at 1,000 psi. We're still at about 18 amps. Pump's fully de-stroked. We've got pressure, no flow, therefore very little drag, very little load on the electric motor. And I'll come over here and I'm going to back this down until I'll see the gauge move a little bit. What I'm really looking for is sound and seeing the amp meter starting to rise. Now you can hear it. Okay, back off right. Okay, we're at about 18.1 amps, and I can hear some fluid moving in this tube. At that point, I'm going to lock my relief valve down. Done. And then we're going to back the pump off, back down to about 800 psi. Lock the pump down, and we come over here and fill the block. We can't hear any fluid flow. It's not getting hot. And now we've got our pump set about 200 psi below the crack pressure of the relief valve, and the system will operate just fine that way.